Simulating and interpreting results. Proceed to simulate while the button automatically show output graph is turned on. Remember that this toggle button being turned on before a simulation allows you to see a dynamic moving chart during the simulation run. At risk will take some seconds to open additional parallel Excel sessions in order to allocate a faster simulation run. Parallel multiprocessing is allowed on at-risk's industrial versions, provided obviously that the computer has multiple core processing capabilities. Once the sessions have been properly opened, at-risk will run 5,000 iterations, and you will see during the course of the simulation the chart on top of M1 being updated many times during its run. It is important to notice that at-risk is also updating any other output cell in the model. In fact, every open cell on any open workbook and worksheet is being updated 5,000 times. However, the fact that the cursor was placed on a specific cell before the simulation was executed makes this output cell the one that will be shown and updated during the simulation. When the simulation has stopped, the following chart for loss should appear completed. Notice the mean at 844,000. This implies that, on average, this loan portfolio is bound to accumulate average losses of that amount. Theoretically, this mean should converge to the total expected loss of 813,958, calculated deterministically on K1. The fact that its results are slightly higher than the stochastic mean of 844,378 is due to the fact that the loss given default function has somehow been artificially truncated for not allowing recovery rates larger than 100%, which are absurd. After 5,000 iterations were run, the minimum stood close to 8,000, whereas the maximum exceeded 3.2 million. In theory, you could run as low as no losses, and as much as losing the whole portfolio for a total of 45.2 million. Both extreme scenarios are highly improbable. 21. Within the graph, now place the amount of the mean on top of the left vertical delimiter. Notice that the x-axis scale is in millions. Therefore, to write the mean, type in 0.844378 on top of the left vertical delimiter. Also, make sure that the right vertical delimiter leaves 5 percentage points on the right-hand side of the probabilistic bar. By doing this, the value on top of the right vertical delimiter will display a value of $1.556 million. This is the 95th percentile. In other words, we can now state that this loan portfolio carries an expected loss of $844,000. It also has a 95th percentile of $1.556 million, meaning that the difference between its 95th percentile and the mean for 711,812 represents unexpected losses at a confidence level of 95%. 22. Change the right-hand side percentage on the probabilistic bar from a 5% to a 1%. This will slide the vertical delimiter to the 99th percentile at $2.053 million. Therefore, the difference between 2.053 minus expected losses of 844,000 leave unexpected losses of $1.209 million at a confidence level of 99%. In other words, the analyst can be 99% sure that beyond expected losses of $844,000, there will be additional unexpected losses of up to $1.209 million on top of them.